Hello students, in this video we will be learning about the basics of trigonometry. Now trigonometry, many students believe it they find it difficult. Okay, but we'll try to make this trigonometry as easy as possible by following certain rules. Okay, so let's first understand what is trigonometry. Just imagine this is a building, a tall building, and you are standing somewhere over here at the foot of that building, and you know the distance from here to here, and you know at what angle can you see the top of the building. You know the height of the building. Can you measure this distance from where you are standing till the top of the building? Yes. With trigonometry that is possible. You can measure this length, you can measure the height of the building if you do not know, if you know the other sides, or you can measure the distance from where you are standing till the foot of the building or the base of the building. This is possible with trigonometry. Remember, trigonometry is applicable to only a three-sided figure and a right angle triangle only. The word trigonometry, by the way, comes from three Greek letters. That is trig, sorry, not trig, just gon and metron. Tri stands for obviously three, gon for sides, and metron for measure, which means we in trigonometry look to measure a three-sided figure, and not just any three-sided figure. We look to measure a closed three-sided figure which we call as a triangle, and in particular a right angle triangle. This is a criteria to apply trigonometry to any geometrical figure that represents a triangle. It has to be right angled. Only right angle triangles can come under trigonometry, especially for your level. So remember, trigonometry comes from the word trigonometron. Tri stands for three, gon for sides, metron for measure, which means we are in trigonometry we measure a three-sided figure. Fine. Now moving further, we said it is a three-sided figure, right angle, right? So we'll draw one triangle over here and we'll give it a name A, B and C. Now this is your altitude, which we also call as perpendicular. This is what we call as the base of the triangle, and this is of course the hypotenuse. Remember, we have learnt before that the side opposite to a right angle is always the longest side, and it is called as the hypotenuse, which we use in a Pythagoras theorem. For now, we just look to remember these three sides. This is your perpendicular, this is your base, and this is your hypotenuse. Now what we'll do in this is we'll take just the first letters of these three words. That is, for perpendicular, we'll take the starting letter P, then we have base, and we'll take the starting letter B, and hypotenuse. The starting letter one is H. So we need to remember this P, B, H. And why? I'll let you know. The next thing we need to know is about angles. Angles within this triangle. So when we look to measure certain distances or heights, if it is at an elevation, or let's say we are looking from top to down, angles are always involved because we are looking at a particular angle. From bottom to top we look at a particular elevation, that is an angle. Okay, this would be the angle that it would form with the base. If we are looking from top to down, then we form angle that will represent this way. Okay, from top to down, that is called as a depression. That is not necessary right now. Right now we just focus on a particular angle. Let's see the angle formed here is theta. Okay, now theta is the 8th letter in the Greek alphabet. Fine, just like how we have A, B, C, D, E, F, G, we have theta at in the 8th letter of the Greek alphabet. And here it is just representing an angle. We can take an angle, can be just A, B, C. In this case, the general form I'm taking is just theta. So now we have certain ratios. We look to represent certain. We look to represent the sides in a triangle in particular ratios, and there are certain names given to them. Like for example, you have sine, which we in short form just say sine this way, or cosine, which we call as cos. Then you have tan, you have cot, you have sec, and you have cosec. Okay, these are give you different ratios. These represent different ratios. As in the sides. Okay, the ratio of the sides, and we look at those ratios. Now, for example, the word sine. The first time anybody used sine was our very own Greek mathematician Aryabhat. So we should feel proud about that. That he started using trigonometry, and we have many since then: sine, cos, tan, cot, sec, cosec, all representing various ratios. Now, if theta is the angle, okay, then the side opposite to theta will be which one? AC. So this will be the side opposite to theta, or we can say angle B. What about BC? BC will be regarded as the side that is adjacent. Adjacent means next to. Okay, so this side is next to this angle. Side adjacent to theta or angle B. And this is of course the hypotenuse. So these are sometimes it is used opposite upon adjacent, or adjacent upon opposite, or opposite upon hypotenuse, something like that, to relate to the different ratios that we talk about in trigonometry. Now, all these I told you are in particular ratios: sine, cos, tan, cot, sec, cosec. Remembering this, what is sine, cos, tan, cot, sec, cosec, becomes difficult. Okay, and as more and more formulas come into picture, remembering all of them becomes a big headache, and ultimately we don't remember anything at all. So we'll devise one mantra that helps us to memorize, okay, what is sine, what is cos, what is tan, cot, sec, cosec, and it will make our life way much easier. So what is that mantra? So that mantra is this: P B P H H B. Now you may say, what is P B P H H B? Now we'll have a look what is P B P, and for a moment I'll just erase this part. Okay, sine, cos, tan, everything, and let us just focus on this particular figure that I have drawn. So P over here stands for this perpendicular, B stands for this base, P again stands for this perpendicular, repeated once again, and H stands for this hypotenuse. So both these H's stand for this hypotenuse, and B is of course for this base. Now you may wonder, what is PBP and how do we remember this thing? So we remember this thing as this: Pandit Badri Prasad Har Har Bole. Okay, memorize this: Pandit Badri Prasad Har Har Bole. Just imagine Pandit Badri Prasad Okay, as a devout person, as a religious person, as a sadhu, you can say, and he keeps chanting Har Har Bole. So Pandit Badri Prasad Har Har Bole. Just keep saying this in your mind. Pandit Badri Prasad Har Har Bole. Why do we remember Pandit Badri Prasad over here? Because if you notice carefully, the first letter of these words or of his name, Pandit Badri Prasad, represent these letters PBP. Har Har Bole. HHB. Now, why do we need Pandit Badri Prasad in trigonometry? Yes, we need him to make our trigonometry very, very easy. So let us see how does he make our life easy. So let me write down all the important ratios. Sine, we have cos, we have tan. Then we have cot, we have sec, and we have cot. Now how do we remember? And all these are theta because these are representing angles. Fine. So what are these angles are represented in particular ratios. Basically this angle is referring to this angle, and the ratios will be of these particular sides, these three sides of this triangle. So sine theta, remember this P upon H, cos theta B upon H, and tan theta P upon B. Now we'll come back to this. Okay, just keep writing. Now, so this is sine when we read it from top to bottom. This is cos again when we read it top to bottom, and this is tan when we read it top to bottom. Now, if we read it bottom to top, we'll get our cot. Reading it this way. So cot theta will be B upon P, sec will be H upon B. Just go the reverse way that you came, and cot will be H upon P. Okay. Once again we'll go through, and don't get confused at this moment. Just follow what is happening. Sin theta I said is P upon H, cos theta I said is B upon H, tan theta is P upon B, cot theta is reverse now. We came down, now we go back to where we came from. B upon P here, sec will be H upon B, and this will be cosec theta. Cosec theta will be H upon P. Now what is this P, H, B, H, P, B? Once again we'll go back to where we got this P and H and B from. What is P? P is this perpendicular. H is what? Hypotenuse. Which means what is it trying to tell us? What is sin theta actually? See, sin theta we got from our Pandit Badri Prasad as P upon H. What is P? P is our perpendicular, fine. But what is it actually? It is the side opposite to the theta, that angle. So that is opposite. And upon what is it? It is saying H, P upon H. P is this, H is hypotenuse. So it is opposite upon hypotenuse. And if we put it in terms of the letters that we have given for the sides, it would be AC upon AB. So when we are given sin theta, when we are given a particular angle, okay, to find the sine, when we say finding the sine of a particular angle, we are referring to two sides. Which are those two sides? The side opposite to the angle in question, that is a perpendicular, and the side which is opposite to the right angle, that is the hypotenuse. Okay. In plain mathematics, when you go through your textbook or through your notes given by your teacher, it will only be saying sin theta is equal to opposite upon hypotenuse, which is opposite to this angle upon hypotenuse. But remembering what is opposite, where does opposite come, where does hypotenuse come, where does adjacent come, becomes difficult. That is where Pandit Badri Prasad Har Har Bole comes very, very handy. So try and remember this person and this chant. Pandit Badri Prasad Har Har Bole. Pandit Badri Prasad Har Har Bole. First PH is sine, then is cos, then is tan. Then we go back. Then comes cot from bottom to top. Then comes sec. This is your sec, bottom to top. And this is your cosec, which is again bottom to top. And this way it will find it easier. So sine theta we got as P upon H, which we got as opposite upon hypotenuse, which is AC upon AB. So what is cos theta? Similarly, cos theta as per our Pandit Badri Prasad is B upon H. What is B over here? B is your adjacent and H is of course hypotenuse. What letters we have given for the base? BC, and hypotenuse of course is AB, right? Similarly, tan theta. Tan theta is your P upon B. Sorry, P upon B. This way, P upon B. What is P? Your perpendicular, but actually it is the side opposite to the angle theta, and B is your side adjacent to the angle theta. So opposite upon adjacent, which means AC upon BC. AC upon BC. Fine. Now moving further. So this was your sine, cos, tan. And the remaining cot theta, sec theta, cosec theta are just opposites of this. Going reverse, from cot is the opposite of tan, then sec is the opposite of cos, and cosec is the opposite of sine. Remember, cosec is not the opposite of cos. Do not make that mistake. Cosec is always the opposite of sine theta. So we'll go to the next one, that is cot theta over here. Put a line over here. Then you have cosec theta. What is cosec theta? Sorry, cot theta. We'll do first. Cot theta. What is cot theta? B upon P. What is B upon P? B is adjacent and P is perpendicular, which is opposite. So if you notice, cot and tan are opposite to each other. What was numerator in tan has now become the denominator. Have a look. Compare it. And what was the denominator, that is B, is now become the numerator over here in cot. Same thing proceeds with sec, but we will complete cot theta first. So cot theta is adjacent upon hypotenuse. So BC upon AC, opposite of tan theta. Then you have sec theta. Sec theta is H upon B. What is H? H is your hypotenuse and B is your base, which is adjacent. Okay, once again, opposite of cos. Cos was what? Adjacent upon hypotenuse. This is hypotenuse upon adjacent. So just the opposite of this, and we can write this as AB upon AC. Okay, sorry, AB upon BC, not AC. Hypotenuse AB upon adjacent BC. And you have cosec theta, which is H upon P, which you can write as hypotenuse upon opposite, and hypotenuse is AB and perpendicular or opposite is AC, right? So this is how we get our first 6 formulas and the most important one: sine theta, cos theta, tan theta, cot theta, sec theta and cosec theta. And how do we get that? From this person, Pandit Badri Prasad Har Har Bole, P B P H H B. If you write that, Pandit Badri Prasad Har Har Bole, and just take their partners together, okay, partners which are in a column, right? Then we will get sine, cos and tan. And then the reverse, when we go from bottom upwards, we get cot, sec and cosec. This is how you get the first set of trigonometric ratios and the most important ones. Okay, that is sine, cos, tan, cot, sec and cosec. Now, what if this angle is not over here, but it is over here? Will the ratios remain the same? See, when the angle was here, I'll give a different name over here. Let's say this is x, okay, and I'll keep this as theta over here. Now, will the ratios remain the same? That is, what I'm trying to say is sine theta. Okay, we got from our sine theta was p upon h, fine, and p upon h is what? AC upon AB, right? Remember, the perpendicular is what we look at angle that is opposite to the angle in question, which is over here. The angle is here and the perpendicular is here. So that is why we have P upon H. But what if the angle now that we have, the new angle, is over here and not here? That is, we are looking at sine of x. Remember, this sine and this theta are not multiplied. They are not, it is not like a into b. Okay, it is not a into b. This is a function, trigonometric function, sine theta, and theta represents the angle. So sine of that particular angle we are looking. These are not multiplied products, so they can't be separated out and can't be divided. So sine of x, let's say our angle is here now. So then our main ratio that we have learned from Pandit Badri Prasad remains the same. That is, sine x will be P upon H. But now, where is the perpendicular? Where is the hypotenuse? Does that also remain the same? No, it changes. Now what happens is, what was the base for theta becomes the height, because we look at the angle that is opposite, we look at the side which is opposite to the angle, which is BC. To make it easier, what I'll do is, I'll just turn this entire triangle clockwise, okay, and draw it again. So when I do that, the triangle will look something like this. All I did was I tilted it this way, fine. So now what is your A that was on top comes down, okay, then your C comes here, and your B which was down goes on top. Got it? You see the difference? A which was on top is now come down because I moved this. Just imagine moving this entire triangle this way, such that we have got A coming down, C going here and B going on top. So B goes on top over here like this. The perpendicular remains at C. That doesn't change at all. Okay. So the hypotenuse you don't have to bother about. It will continue to be AB. But now the height has changed because our angle is here, which means this becomes our height, BC. This becomes our perpendicular. And this becomes our base. What was our height in the previous case? So sine x will be perpendicular, which is BC, upon base, which is AC. So opposite of this. Okay, remember these are two different things. Do not mix up with sine and cosec. Okay, those are two different things. Those are trigonometric ratios which are opposite to each other. Here they are becoming opposite because the angle has changed from here to here. This is now the angle, not this. So when you look, the height and the base changes with respect to the angle, where the angle is formed. Because the angle is formed over here, and you don't have to draw this diagram. This is just to show you how the triangle will change with respect to the angle in question, whether the angle that we have to find out or this trigonometric function of that particular angle that we need to find out is over here or here. The sides will change, and there will be only interchanging between the perpendicular and the base sides. Hypotenuse will always remain the same. Remember, hypotenuse will not change. Hypotenuse will always remain the same. Just the your perpendicular and your base will vary or change. Got it? So consequently, all other trigonometric functions, that is your cos, tan, cot, sec or cosec, will change with respect to the angle. But one thing will remain constant, and that is this Pandit Badri Prasad Har Har Bole mantra or chant. Just remember this, and remember what does that PBP stand for and HHB stand for, and it is important to write them in that particular order, that is Pandit Badri Prasad Har Har Bole. If you write them in that particular order, then only you will get your sine, cos, tan and other trigonometric functions correct. Got it? So I hope this video has been able to make your life a little bit more easier in understanding the very core basics of trigonometric functions, of the trigonometric ratios. That is very, very important to actually understand and get a grasp of the entire chapter. So if you have liked the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to be notified whenever new video is posted. Thanks for watching. See you in the next video.